One thing I love about learning is when, after learning all the theories, all the explanations given by the teacher, you get to solve questions to test your understanding of the concepts. That is so valuable and interesting because the more questions we solve, the better prepared we are for our exams. So here is an interesting question. Basically, chemistry, purely chemistry. But what is interesting about this lesson is, it's not just about answers. We are not just going to spit out answers to you, but rather we are going to give you interesting, detailed explanations. And more importantly, where there are chemical reactions or formulas of acid or bases involved, we are actually going to do our best to give you explanations to clarify things that you might not understand. So if so far you've actually not subscribed to our channel yet, before we start, go there and hit the subscribe button, possibly like this video, and share even before we get started. So let's see. A class of students prepare common salts in the laboratory by first reacting an acid with a base. So that means there's some kind of reaction between an acid and a base going on. And then the final result, the resulting solution from the first part of the experiment, is then carried on to the next stage. So it continues by saying that the resulting solution is then separated to obtain the salt. So we have to study these processes carefully and answer the questions that follow. So here we have two setups, setup A and setup B. The setup A is showing the reaction between an acid and a base. Then setup B is showing the separation of the salt from the solution. So let's get started. So the first part of our question or our task is to name the apparatus that appear in our setup. So we have I, IV, and VI. So what are they? This actually is very straightforward. For the I, that is a clamp or burette clamp. That makes sense because you can see that the I is just a standing clamp holding on to something. And the thing it is holding is known as a burette. So that is why we name it as a clamp or a burette clamp. Then the II is known as a burette. So a burette is just also a measuring instrument or a measuring apparatus, because when it comes to titration, it helps us to hold the titrant, that is the solution whose concentration is known. So for example, you can see that the II, which is the burette, has a certain liquid in it. So the burette has calibrations on it. So these calibrations help the one performing the titration to actually know the volume of substance or liquid. In this case, either an acid or a base that needs to be taken for the experiment. Then the IV is the conical flask. Then the V is the evaporating dish. So these are the apparatus that we have in our setups A and B. Now let's move on to our next question, question number 2. We have been asked to give 2 examples each of II and V with their chemical formulas. So before we can give examples, we have to know what they are. So we have II and V. And it is obvious that the III and V are actually liquids. So what type of liquids are they? So let's get straight to the answer. For the III, that is an acid, based on our understanding on titration. So a little bit background on what titration is basically about. To put it simple, in titration, there is this setup where, as indicated in setup A, we have a liquid that will be poured in the burette. But when I say a liquid, I'm not referring to any kind of liquid. In this setup, is basically an acid, which in titration is referred to as a titrant. And then a base will be poured into a flask, in this case referred to as the analyte. So what happens is that the person performing the titration is trying to look for the quantity of the acid that is in the burette that will react with the base in the flask. So basically that's what happens. And normally we have a titration basically between an acid and a base. That's the lowest level explanation I can give you. As you proceed in your lesson, you'll get to understand more about titration, especially when you get to senior high school when you are doing elective chemistry. So let's get back to our question. So we have been asked to give 2 examples of III. So first, we've gotten to know that III is the acid. And what are some examples of acids we know? We have hydrochloric acid and sulfuric acid. The formulas are what appeared on the screen. Hydrochloric acid is HCl and sulfuric acid is H₂SO₄. What about the V? What is that? The V is the base, also known as the alkali. For the base examples, we have sodium hydroxide and then potassium hydroxide. Here are some examples of bases with their formulas. So what other examples of bases do you know? Well, you can go ahead and write the answers in the comment section. And take note of this. When it comes to titration, normally the acid goes into the burette while the base goes into the flask. But it is not a rule cast in stone. The reverse is also possible, especially when it comes to a titration between a weak acid and a strong base. Sometimes the base can go into the burette, but normally or usually acid with a known concentration goes into the burette, then a base goes into the flask. Now let's look at our third question. We are to give 2 properties each of III and V, or in other words, we have to give 2 properties of acids and then bases. So let's go straight to the acid. For the acid, they have a sour taste. So every acid, hydrochloric acid, sulfuric acid, any type of acid at all, has what? A sour taste and turns blue litmus paper red. For turning blue litmus paper red, what that basically means is if you have an acid like the ones we have on the screen and you take some drops and release them on a blue litmus paper, the color will change from blue to red. These are some 2 properties of acids. What other property of acid do you know? You can write the answer in the comment section for us to see. Then the properties of bases, they feel soapy or slippery to the touch. So if you have the chance to feel a base, you realize that it has a soapy feel or a slippery feel when touched. What about turning litmus paper? Bases turn red litmus papers blue. So what that means is if you take sodium hydroxide or potassium hydroxide, which are bases, and you pour some drops of them on a red litmus paper, since they are bases, they will change this red litmus paper to blue. So far our first 3 questions are actually just straightforward questions. Easy peasy, right? Now let's turn on the gas a little to somewhat quite difficult questions. That's question number 4. We are to write 4 examples of chemical equations or reactions involving III and IV. What does that mean? So we have III, an acid, and V, a base. So we have to write a reaction between acid and a base. So this type of reaction between an acid and a base is basically known as a neutralization reaction. A neutralization reaction. So a neutralization reaction is basically a reaction between an acid and a base to form salt and water. So what does that mean? If you look at setup A, for setup A, there is an acid in the burette, and then there is a base with an indicator in the flask. So the acid will be dropped bit by bit into the base in the flask to see at what point will the base change color, indicating the end point of the reaction. So this type of reaction between the acid and the base is known as neutralization reaction. And the end result, the resulting solution that will be formed, will be basically salt and water. So you have to write 4 examples of chemical reactions involving this acid and base. And we have 2 examples on the screen already. We have HCl plus sodium hydroxide. HCl is hydrochloric acid and NaOH is sodium hydroxide. If you react hydrochloric acid and sodium hydroxide, the end result or the products that you have will be sodium chloride plus water. What about our next reaction? That is H₂SO₄ or sulfuric acid. So sulfuric acid plus KOH, that is potassium hydroxide. So sulfuric acid plus potassium hydroxide will give you potassium sulfate, K₂SO₄, plus water. So these are 2 examples out of the 4 that we have. Now before we proceed with the next 2 examples of reaction between an acid and a base, let's give some little explanation to how these chemical reactions are written. So let's pick the first one, that is hydrochloric acid plus sodium hydroxide, giving us sodium chloride and water. So the hydrochloric acid, which is the HCl, and then the sodium hydroxide, that is NaOH. The 2 of them are known as reactants. That means they are the ones undergoing the reaction. HCl is the acid and NaOH is the base. As they react, they form salt and water. The salt is sodium chloride and H₂O is the water. So that is the equation or reaction that we have on the screen. But how did we get to this point? So let's do some kind of reverse engineering to see how that happened. So our first step is to break each of the reactants, that is HCl and NaOH or sodium hydroxide, into their respective ions. So if you pick the HCl, for example, that is hydrochloric acid, when we break it down into its ions, we have H plus and Cl minus. So the H plus is the cation and Cl minus is the anion. If you remember correctly what ions are, we say ions are charged atoms, electrically charged atoms. And ions come about when atoms either gain or lose electrons. And cations are basically positive ions and anions are negative ions. Cations are formed when an atom loses electron. And anions are formed when an atom gains electron. When an atom loses electrons to form a cation, what that means is that it becomes net positive and anion becomes net negative. So that's a brief recap on how ions are formed. So for HCl, its ions are H plus and Cl minus, meaning H plus and Cl minus came together to form HCl. What about sodium hydroxide, NaOH? When we break it down into its ionic form, we have Na plus, that is the cation, NaOH minus, that is the anion. So you have Na plus OH minus coming together to form the sodium hydroxide. That's how each of these reactants came about. Now, one thing you should notice, although we wrote the reaction as HCl plus NaOH, giving us or going into NaCl plus water, it is these ionic forms that actually go into the reaction. How is that the case? For a compound to be formed, for example, like this one, we have a cation bonding with an anion. So the cation from the HCl is H plus, will bond with the anion from the NaOH, which is the OH minus. So H plus plus OH minus will give us the water in the final reaction. And then the cation from the sodium hydroxide, that is Na plus, will also react with the Cl minus from the HCl. So Na plus plus Cl minus gives us NaCl, that is the sodium chloride, a table salt, a common salt. So these two, that is the water and the sodium chloride, are known as the products. So you see how we came by this chemical reaction? So HCl plus NaOH will give us the salt, sodium chloride plus water. Now, after writing any kind of chemical reaction, no matter how basic it is, what you have to do next is to check and balance the reaction. So how do we check and then balance this reaction? Sometimes you can check a reaction and to already be balanced. Sometimes it should not be balanced and you have to do something about it. So how do we check to see if this reaction is balanced or not? The first step is to identify the reactants and the products. For our reaction we have on the screen, the reactants are HCl and NaOH, or hydrochloric acid, and sodium hydroxide. These are the reactants. After identifying the reactants, what you have to do is to write each atom present in the reactants, or each of the elements you see. So for our reactants, these are the elements. We have hydrogen, we have chlorine. You see the hydrogen, we know the hydrogen is there because of HCl. Then the next one is chlorine, Cl from the HCl. Then we have sodium. You see sodium in the sodium hydroxide. They have oxygen. We've also indicated the oxygen. They also have hydrogen again, but we've already written the hydrogen at the top. So these are the elements we have in the reactant side. What about the products? The issue is, for every chemical reaction, the elements present in the reactant side are also present in the product side. So for the products, but you can cross-check anyway. We also have hydrogen, chlorine, sodium, and oxygen. Hydrogen from the water, chlorine from the sodium chloride, sodium from the sodium chloride, and oxygen from the water. So that's the first thing to do. And then after that, you then proceed to identify the number of each of the elements present. How can you tell the number of each of the elements present? You check the subscripts. What do I mean by the subscripts? The subscript refers to the number written at the bottom of each of the elements. For example, we have HCl from hydrochloric acid. There are two elements. They have hydrogen and chlorine. For the hydrogen, the subscript is 1, although 1 is not written there. Whenever a number is not written, know that it is 1. So the subscript is 1, and then for the chlorine too, the subscript is 1. So check for the sodium, oxygen, and hydrogen, and you notice that for the reactant side, they are all 1, 1, 1, 1. But there's something unique about the hydrogen. There is one hydrogen in hydrochloric acid plus another hydrogen in sodium hydroxide. That is why we wrote 1 plus 1. Good. Now let's move to the product side. We have hydrogen, chlorine, sodium, and oxygen. If you look at the hydrogen, this hydrogen is in the water. What is the subscript of H or hydrogen in the water? I'm sure you got it right. That is 2. The subscript is 2. What about chlorine? Chlorine is 1. So you can check for the rest and see. But if you've done a good check, you realize that hydrogen is 2, chlorine is 1, sodium and oxygen are also 1. Now, after we've gotten all of these values, we have to compare their total for the reactants and the product. For hydrogen, 1 plus 1 is 2 for the reactants, and for the product is also 2. And what about the rest? Chlorine is 1 for reactants, 1 for product. Sodium, 1 for reactants, 1 for product. Oxygen, 1 for reactants, 1 for product. So what does that mean? Since the values for the reactants and the product are the same, we can say that our equation, our final equation is already balanced. So we really didn't have to do any balancing at all. But I just took you through this process so that you know that after writing any chemical reaction, you have to check whether the reaction is balanced or not. If it is already balanced, then you are fortunate. If it is not already balanced, then you have a work to do. You have to balance it yourself. And that is what will happen in the second example. That is sulfuric acid plus potassium hydroxide, giving us potassium sulfate and water. So let's look at that one also and see how the reaction actually came about. Let's give some little explanation. Are you ready? Well, before you proceed, if you've not subscribed to the channel, what are you waiting for? Go down there. Let me give you some time. Go down there and subscribe. Give the video a like if you are actually enjoying the lesson, and try your best to share with other students you know who benefit from this kind of lessons. So let's continue. So we have this reaction. Same explanation. We are on the second one, of course. Take note of that. So you have H₂SO₄ plus 2 KOH going into K₂SO₄ plus 2 H₂O. So how did this equation come about? Now, first of all, let's break the ions, or let's break the reactants into their respective ions. And as we are doing that, do your best to ignore the numbers we have in front. For example, the number you have in front of the KOH, or potassium hydroxide. Ignore that number for now, and also ignore the number in front of the water, that is H₂O. The reason I'm asking you to ignore them is that the equation you see at the top is actually a balanced chemical equation or reaction. So I'm going to teach you how to write it and then how to balance it to get the reaction or equation you have at the top. So let's get started. Breaking of the products into their respective ions. We have H₂SO₄. H₂SO₄. For the H₂SO₄, its ions are H plus and SO₄, 2 minus. The H plus is the cation ion. The SO₄, 2 minus is the anion. Don't be confused. You see, especially for the SO₄, 2 minus, you'll be asking yourself, why is 2 at the top? 2 minus, why is it 2? Take note. The 2 in front of the H, you see the H subscript 2 SO₄, that 2 in front of the H actually came from the SO₄. So that 2 is from that side. So the 2 is from the H subscript 2. and the H plus is just +1. You see, don't be too scared. The more you practice this kind of chemical equations, the better you become when it comes to writing them into their various cations and anions. And when you even become better at writing this kind of reaction, you don't even need to write the cation and anion form before writing chemical equations. What about the KOH? The KOH can also be broken down into K plus and OH minus. And like we did in the previous one, the cation from the acid, which is H₂SO₄, will bond with the anion from the base. And the anion from the base is OH minus. So H plus OH minus gives us water. Gives us water. Gives us water, H₂O. Then the K plus, that is the cation, will react with the SO₄2 minus from the H₂SO₄ to form K₂SO₄, and that is the salt. But here's how interesting it gets. The two subscripts, the K2, that subscript 2 is actually coming from the -2 on top of the SO₄2 minus. So that's how interesting chemistry can be sometimes. The H₂O, that is the water and the salts, are collectively known as the products. So let's keep that in mind. So now let's combine the products and the reactants. The reactants are H₂SO₄, that is the acid, and then the base KOH, potassium hydroxide. These two, H₂SO₄ plus KOH, react to give us the product K₂SO₄, or potassium sulfate, plus water. Now this is our reaction between an acid and a base to form salts and water. And remember, a reaction between an acid and a base to form salt and water is known as a neutralization reaction. But as usual, we have to check if this reaction is balanced or not. So next step, checking and balancing of reaction. Are you ready? Remember, spoiler alert, this reaction is not balanced. So let's try to balance it. First step, what do? Well, before we go ahead to go through the steps, let me just rewrite this reaction, the unbalanced one, the one you see at the top. Let me just repeat it at the down, because we'll be doing some kind of operation on it. So pay close attention. Things are going to get quite tricky and interesting. But don't be discouraged. I believe you will be able to do it. Are you ready? Okay, if you are ready, then subscribe to the channel if you haven't. Subscribe to the channel fast before we proceed. Okay, so let's go. Now, first things first, we have to identify the reactants and the products in this reaction. So, what are actually the reactants? Have you found them? Yes, I know you have. That is the acid and the base, H₂SO₄ and KOH. So if you identify the reactants, what you have to do is to write out the elements we have at the reactant side. So what are the elements? For H₂SO₄, we have hydrogen, we have sulfur, we have oxygen, they have potassium. Then you see that oxygen appears in the potassium again, the hydrogen appears. So here are the elements in the reactant: hydrogen, sulfur, oxygen, potassium. Remember, we've not repeated the hydrogen twice, yes, and we've also not repeated the oxygen. We only need to write one of them. What about the product side? Remember, the elements found at the reactant repeats at the product side. So for the product, we have hydrogen, sulfur, oxygen, potassium. After writing out the individual elements, what do we have to do? We have to write the number of them we have in the reactants and the product. So for hydrogen, what do we have? We have, for the sulfuric acid, H₂SO₄, you realize that the hydrogen has a subscript of 2. So H₂SO₄. So the subscript of hydrogen is 2. So you have 2 hydrogen over there. Then we have another 1 hydrogen at the KOH. Do you see that? KOH. So that's another hydrogen. So 2 plus 1, that gives us 3. But here's the point. We do not write 3 just as 3 that way. Write them as separate. So you write hydrogen, you have 2 plus 3. Then check for the sulfur, oxygen, and potassium. For the sulfur, we have 1. For the oxygen, we have 4 in the sulfuric acid and 1 in the potassium hydroxide. And for the potassium, you have only 1. So this is how to write out the various elements and the numbers you have in each of the compounds. So hydrogen 2 plus 1, sulfur 1, oxygen 4 plus 1, and potassium have 1. If at this point something is quite not clear, then quickly run to the comment section. Really run, like literally run to the comment section and write your confusion or explain yourself what you need help in your comment section. Now let's move on to the product side. For the product side, hydrogen, sulfur, oxygen, potassium, we have, these are the quantities we have. Hydrogen 2, sulfur 1, oxygen 4 plus 1, potassium 2. I think you should know why we wrote the numbers that way. Now let's cross-check and see if this chemical reaction is balanced or not. For hydrogen, we have 2 plus 1, that gives us a total of 3. 3 of the hydrogens are the reactant side. What about the products? We have only 2. So the 3 at the reactant is not the same as the 2 at the product. So that means the reaction is automatically not balanced. But we can check the rest. Sulfur is 1 at the reactant and 1 at the product. Good. Oxygen, 4 plus 1 is 5. And for the product side as well, it is 4 plus 1, 5. So it's also the same. For potassium, it is 1 for reactants, 2 for products. So that means the entire chemical reaction, that is sulfuric acid, the acid plus potassium hydroxide to give us potassium sulfate and water, is not balanced. So how do we balance? How do we balance the chemical reaction? The one we have on the screen, how do we balance it? Easy peasy. Yes, it's really easy, like literally easy. Sometimes as students, our problem is we get so scared. We fear problems that actually do not exist. So believe when I say it is easy, just pay attention. If so far there's something quite confusing, don't worry, maybe this is the first time. Take your time, watch the video over and over again. So you see how much I've taken my time to explain? That means I know you'll be able to get it. So let's see how to balance this chemical reaction. How do we do it? Here are the rules. When it comes to balancing chemical reactions, you will just look at the side, either reactant or product, the one that is lacking, and then look for a factor or look for a number you can use to multiply, not add. You can use to multiply the lacking side to make it equal to the one that is more. What does that mean? For example, I'll start from the one at the down, the potassium, the K. You realize that the potassium is 1 for the reactants. But when it comes to the product, we have 2 of them. What can you do to 1 to make it 2? Remember, you multiply, we do not add. So what can we do to 1 to get 2? I think you guessed it. 1 times 2 will give us 2. So what does that mean? So we just pick the 1 for the potassium and multiply it by 2. So 1 times 2 will give us 2. So now you see that the potassium at the reactant side is now equal to the potassium at the product side. You see, I told you it will be very easy. Yes, so first obstacle out of the way. So now what do we do with the 2? This 2, you will write it in front of the potassium compound, the one KOH. Write the 2 in front of it. Remember, the values you use to multiply, you write them in front. You don't write them as subscript. So you write them in front. And after writing them in front, that means it's going to affect what you are doing. So now look at, so the potassium is now 2, and the potassium for the product side is also 2. But here's one interesting thing. Take note of this. Remember, or you've seen that we've written 2 in front of KOH, but we've done something interesting. The 2 affects not only the K, or not only the potassium, it affects the oxygen and then the hydrogen. That is what is happening. So the 2 if placed there is affecting the oxygen in the KOH and then the hydrogen in the KOH as well. So that means the 2 is going to multiply the oxygen and then the hydrogen. Are you confused? Sorry, don't be confused. Take your time. Rewind, play, take your time, understand, proceed. What did we say? You see, we're trying to actually balance the potassium. But when we did and placed the 2 in front of the potassium hydroxide, it affected the oxygen and the hydrogen. So we have to indicate that as well. And take note, the times 2 for the oxygen, you realize that we didn't put the times 2 in front of the 4. But I placed it, we multiplied the 2 with the 1 rather. Why is that the case? Because that 1 is from potassium hydroxide. The 4 of the oxygen is from H₂SO₄ or sulfuric acid. Meanwhile, the 2 is multiplying the oxygen from the potassium hydroxide. And the same principle applies for the hydrogen. So I think that makes sense. Good. So we've solved the problem, but I think we've created another problem. So let's check our elements and see if they are balanced. For the potassium, we have 2 for reactants and 2 for products. Good. For the oxygen, we have, remember, initially we have 4 plus 1, that gave us 5, and it was balanced, but now we've changed it. Now we have the 1 times 2 is 2, plus the 4 is 6. So now the reactant has 6 of the oxygens, meanwhile the product has only 5. Our reaction is not balanced. And then the sulfur is still 1. Intact, and the hydrogen is now 2 plus 2, that gives us 4. How did we get the 4? Remember, 1 times the 2 in yellow, that gives us 2, plus the already existing 2, that gives us 4. So now we have 4 hydrogens in the reactant and only 2 in the product. So that means our balancing is not even complete. What do we do next? We balance. You can start from anywhere, but for this particular question, I feel it's quite easy if I try to balance the hydrogen before proceeding. How do I do it? Remember, we have 4 hydrogens at the reactant side, but 2 at the product side. So what can we do to the 2 hydrogens at the product side to also get 4? You guessed it right. We multiply 2 by 2. So 2 times 2 is 4. So now let's check again. We have 4 hydrogens at the reactant and 4 at the product. So the hydrogen 2 is balanced. But after multiplying by 2, what do we do? Do we just stop over there? This 2 is multiplying the hydrogen, right? It's multiplying the hydrogen in the water. So you have to use this 2 and write it in front of the H₂O. The water molecule, so write the 2 in front of it. I know you are thinking, you not say this is easy? Yes, it is easy. It is easy, but it might look difficult for you. Maybe this is your first time and you know how the brain works, right? The brain likes easy things, repetition. So the more you repeat this, the easier it becomes for the brain to actually understand it. So don't feel your first resistance from the brain means it's too difficult for you to understand. Well, let's continue. So take note, we place the 2 in front of the water molecule. We are trying to adjust the hydrogen in the product side to make it 4. But remember, as you place the 2 in front of the water molecule, it affects not only the hydrogen, it also affects the oxygen. So the hydrogen has become 4, but the oxygen that is attached to the water molecule or attached to the hydrogen also becomes times 2. So at the product side, the 1 over there also becomes 1 times 2. That one is for that 1 hydrogen, or that 1 oxygen is actually from water. So as we are trying to adjust the hydrogen, we have also changed something about the oxygen. So now let's cross-check again. Hydrogen for the reactant, 2 plus 1 times 2, that gives us 4 for the reactants, and 2 times 2 for the product gives us 4. So the hydrogen is balanced now. Sulfur is 1 for reactants and 1 for products. Balance. What about oxygen? For the reactant side, we have 1 times 2 is 2 plus the 4, that gives us 6. So 6 for reactants. What about products? 4 plus 1 times 2, that gives us 6. So oxygen is also balanced. And potassium is also balanced. 1 times 2 is 2 for the reactants, and for the products we have 2 potassiums at the product side. So our final equation or reaction is now balanced. Is it easy? Yes, it is. Go back, replay, take your time, understand. Because the same step can be used for any kind of reaction. We've taken so long on question number 4. So now you understand why I said some of the questions are actually going to involve detailed explanation. And take note, you don't need to write all of this in your exams. You don't need to write them. You just write the equation as it appears at the answer section. I'm just explaining to you how we got them so that I don't have to do chew and pour. Okay, so now let's get back to our question. So we have the next, remember we've already written, let me go back. We've written the first 2 reactions between acid and base, HCl, hydrochloric acid plus sodium hydroxide, that reaction, and then have sulfuric acid plus potassium hydroxide. There are only 2, but our question is demanding that we write 4, so let's write the remaining 2. The remaining 2 are what appears on the screen. HCl plus KOH gives us KCl plus H₂O. Remember, neutralization reaction will always involve an acid and a base giving us salt and water. So take your time to analyze this thing. So let's move on. I think we've taken too much time on question number 4. Our last question, question number 5. Have you noticed the mistake I've made? Question number 4. The next question is supposed to be question number 5. But I still wrote question number 4. Human error. Raise your hands up if you've not made a mistake before. So whilst preparing the notes, I think I forgot to change it. Well, I pray you do not make mistakes, this kind of errors in your final exams. Okay, let's go straight to the business. So we have setup B, a Bunsen burner. Then we have a Petri dish with the mixture obtained from setup A transferred to setup B. And then there's some kind of evaporation going on. That is exactly what is going on in setup B. Remember, in the actual question, we've been told that the salt in the final solution from setup A is retrieved from the solution. So you have to explain the process in setup B. So how do we go by it? So you see, setup B shows the evaporation of a salt solution using evaporating dish placed over a tripod stand with a heat source, likely a Bunsen burner. Yes, this particular one is Bunsen burner. So basically the entire process going on is evaporation. So you have a salt solution, that is salt and water, in a petri dish placed over a heat source. You keep heating until all the water evaporates, leaving the salt in the petri dish. So we have to explain the process. So in setup B, the salt solution obtained from the neutralization reaction in setup A is heated in the evaporating dish. And then, as the heating continues, water evaporates, leaving behind the dissolved salt. The process helps in recovering solid salts from the solution. So depending on the type of acid and base involved in the reaction in setup A, that will determine the kind of salt we received or obtained in setup B. It can be sodium chloride or any kind of salt at all. So this is quite a typical method used in laboratories to obtain a dry salt after a reaction between an acid and a base. So your task is just to read the kind of explanation I've given and see how best to summarize it. So take note, the main part of the answer is simple. What is going on in setup B? For setup B, we have the mixture from setup A placed into a petri dish, heated over a source of fire for the water to evaporate, leaving the salt behind. That is the more concise answer expected. But since I'm giving a detailed explanation, that's why you saw me write so much. You don't need to write all of this. Write it simple, as I've just explained. So this brings us to the end of this lesson. Quite lengthy than I expected. And I think basically it's because of the explanation given at the side involving the reaction between an acid and a base. So what have we studied? We've looked at titration. The question is basically titration. A reaction involving placing a titrant, in this case an acid, into a burette, and then dropping it gradually into a flask containing a base until there is a color change. The color change indicates end of reaction, the end point of the reaction. So basically that's a brief explanation I can give you, not detailed. As you proceed in your level of education, you get to do that. So I think that is that. Yes, I have nothing else to say. I think I have something to say. If you've not subscribed to our channel, please subscribe to the channel. Yeah, and like the video. You see, the more you do that, it helps the channel grow, and the video, the one you are currently watching, will be recommended to other students. And if you have friends preparing for B.E.C.E, or you have someone in secondary school, as the channel we've said somewhere before, this channel is basically to help students. So do not be selfish. Share this good news with other colleagues of yours. So until next time, we'll meet again on Learner's Aid. See you next time.